All right, now let's look at a problem number 15. So problem number 15 says, here we have 5 numbers, 5, 7, ABC, and their mean is 8. And then we want to look at what are those possible values of the median. In particular, which of the following is impossible. Okay, all right, so here we have, so let me write down. So we have the mean, so which is the average, arithmetic average, so divided by 5. This one equals 8. Okay, so from here, so this add together, which is 12, right? So okay, so we get A plus B plus C. The last 3, so equals to so this is 40 minus 12, which is 28. Okay, so in particular, if you take the average of these 3, so this if average 3, so this approximates like 9 point something. So if you look at those numbers, let's see, 10 is impossible because if 10 is the median, so let's say if 10 is the median, if 10 is right here, so that means all those ABC will be no less than 10, right? So all of them will be bigger than 10, no less than 10, less 10, and its average is not going to be like 9 point something. So we quickly figure out 10 is impossible. All right. So median, like median, recall the median means the if you have 5 numbers, median is the one that is in the middle, right? So if it's A, B, C, it's one of them is 10, then the other 2 have to be no less than 10. Okay. All right. Let's look at the second one, the problem number 16. Number 16 is about solid geometry. So we have rectangle box that inscribed inside of a hemisphere, right? So the top 4 corners of the top touch the sphere, and then the bottom is on the bottom of the hemisphere. Okay, so what do we have? So what we know is, all right, so what we know is the radius. So let me draw. All right, so this is the center because everything from center to the symmetry is center to center. So this is center. So if I draw down from this connect this point, okay, so you get this is the height. All right, so now if I connect those 2 things, okay, so this is perpendicular, this is perpendicular, this is perpendicular, this is perpendicular, right? So going down is perpendicular to everything, okay, so the center. Now, well, okay, so what we have is we know the radius. So if I draw the radius, this is the radius, right? Radius from the center to the corner, right, to any point on the sphere. So this guy is 10. Now then you see, if you look at the this picture, right? So this is a 2-dimensional picture, which is rectangular. So if I look at this one out, this is rectangular. And the green one is the one that we want to figure out. And what we have is we know the radius is 10. Okay, so then you see obviously this is obvious. If you have a rectangle, then 2 diagonals are the same. So we immediately get this is also 10, right? We get this is also 10. So that's what we have. Okay. All right. Now let's look at problem 17. 17, we want to figure out, say, okay, we want to write 10 factorial. So let's recall 10 factorial is what? Is 10 times 9 times, so let's put it here. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 3 times 2 and times 1, right? Okay, so we want to find the way that this can be written as the product of even number and odd number, because the order doesn't matter, like which one put okay, so that means basically we are looking for the number. So this is equal to say, well, you just need to find the number of odd factors, right? Odd factors of 10 factorial. All right, so we have a formula to, if given number, we have a formula to calculate the number of factors, and also you can do the number of odd factors. The mechanism is the same. Step 1 is you do prime factorization. So step 1. So let's recall the mechanism. So step 1 is we do prime factorization. Prime factorization means I write this as the product of prime numbers. So by the way, all those things you can find in chapter 4 number theory. Okay, chapter 4 number theory. All right, so we do factorization. So 10 factorial. So 10 factorial, if you look at all the possible prime numbers, you start from 2 times 3 times 5, and times 7, right? You just need to figure out the powers of each one. Now, of course, like if you just care about all the factors, 2 doesn't matter. But let's say to be complete, let's just figure it out. Okay. So for 2, so let's look at 7 because you only want 7. So obviously this power is 1. 5, because here you have 1, 5. Let's see. So here you have 1, 5. Here you have another 5 can contribute. So you have 2, 5. How about 3? So for 3, you have 1 here. You have 1 here. But 9 is 3 squared. So 9 contributed to 3. So 3, so here is going to be 4. All right. So then how about a 2? So 2 is you have 1 here, right? You have to contribute 1 here. Oh, I forgot one number, sorry. So there's 4 here. Forgot a 4 here. All right. So then the 4 is going to contribute, 4 is going to contribute a 2, 2, right? So it contribute 2, 2, okay, because square. And this is 8 is 2 cubed, so it's going to contribute 3, 2. And this is going to contribute 1, 2, all right? So then now if you 2 together is 1 plus 2, so this is 4. Okay, so this is going to be 8, right? So this is going to be 8. Okay, so now if you look for the number of factors of 10 factorial, right? So which is going to be, you see, okay, so any factor of 10, it has to be 2 some power, 3 some power, 5 some power, and 7 power. Now, because it's a factor, so which means the power of each prime factor cannot go beyond the number, the power in the original one. So we have this guy has to be less equal to 8. This is less equal to 4. Well, maybe, okay, let's see. So this is less than 2, this is less than 1. Okay, so that means you go from 1 to 8, 1 to 0 to 4, sorry, 0 to 2, and 0 to 1. Okay, so then the number is 8 plus 1, because we could include 0. So times 4 plus 1, times 2 plus 1, and times 1 plus 1, right? So this is 270. So that's the total number of factors of 10 of factorial. Now here we only need a number of odd factors. So number of odd factors, right? Odd factors just means you just look at 3 to 5 to this to 7 to this. All right, so that is similar. So this the power could be go from 0 to 4. So here the power could go from 0 to 2. So here power 0 to 1. Okay. So the number is equals to so this is 4 plus 1 times 2 plus 1 and times 1 plus 1, right? So that this one is 30, right? We get is 30. Okay. Now this is basically due to a multiplication principle, right? So why this is the multiplication? Because of the multiplication principle in counting problems, right? You have different number of choices for each component, and then if you combine together, what you do is you do a product. So in general, so this is okay. So this would have. So in general, so I'm going to make the general statement, which is in chapter 4. All right. So suppose I have a number n, I have a prime factorization. So I have this, let's say P1. So to make a general statement, I have to use algebra, which means I'm going to introduce the Laplace. All right, so I have P1, so that I have P1, which is R1, and P2, R2, and there's a PK, RK. So those are all prime numbers. So this is so-called prime factorization. And each RK, each one, this is begin 1, begin 1, begin 1. All right, so the number of factors is, well, the mechanism is the same because each one you can go from 0 to R1, 0 to R2, 0 to RK. So that's just R1 plus 1 times R2 plus 1 and to the RK plus 1. Okay, so this is how we calculate the number of factors. All right. Okay, so now let's look at problem number 18. So number 18 is again a problem about probability, right? So Maya's class had 20 students. So her teacher wanted to split the class into equal into 2 groups. One goes to the morning meeting, and the other goes to the afternoon meeting. So the question, what is the probability that Maya and her friend Joe, they do a meeting in the morning, all right? So we have two ways to do. So the first one is we go with the standard method. Right? So method one. This one I call standard. So especially I recommend this method for those first learners. Like if you're not very familiar with probability, then you should go with this one, because for this one it's less likely to make a mistake. Okay, but of course sometimes this might not be the most efficient one, but I would say in many cases, in most cases, the most reliable one. Okay, all right. So standard one is we just apply the formula. Right? So say let's recall the formula. So this is the collection of all possible scenarios, and you want to find the probability A, right? So this is just okay. So just the number of valid cases divided by the number of total cases, right? Okay. So here, what is the number of total cases? What the teacher wants to do is to split the 20 students into the morning and afternoon. So this is morning and the afternoon, right? So this is the morning session, afternoon session. Now it's 10 students, and in total is from the 20 students, right? So 10 is from total is 20 students, and you split into two groups. So of course the total is that you want to set up for the morning one. All you need to do is you from 20 you choose 10, right? So this is the combinatorial. So 20 choose 10 to determine the morning group, right? So what are those number of valid cases? Right, so what is the number of valid cases? The number of valid cases is, we just look at, so this, again, this is the morning session and this is afternoon, right? So the valid cases means Maya and her friend Joe, they have to be in the morning. So then all you need to do is you need 80 more students, right? So, okay, so you need to do, you need 8 more students, oops. So you need 8 more students to fill the morning session, but this 8 will be from the remaining 18. So you have remaining 18 students to choose 8. So that will be 18 choose 8. So that's the total number of valid cases. Now, what left is just the fractions. You apply the formula. So the probability will be, so the probability of the scenario equals the total 20 choose 10, and this is 18 choose 8. Okay, so now the question is, how should you simplify this? Now, let's recall the combinatorial. So n choose n, what is the formula? Well, there are 2 equivalent ways to represent the formula. One is you go with n minus 1, and that times n minus n plus 1, and divided by n factorial, right? So this is one way. Equivalently, this guy you can write as n factorial times n factorial times divided by n factorial and n minus n factorial. It's the same, you can check. All right, okay, so then if I go with this guy, if I put it here, right? Well, you can choose either way, whatever you like. I prefer this one because it's easier for me. So then this one is 20 factorial, 10 factorial, 10 factorial. And on the top is 18 factorial and 8 factorial, 10 factorial. All right. So I get 10 factorial cancel with each other. What I have right here, I'll be 20 factorial times 8 factorial, and this is 10 factorial times 18 factorial. Well, then I can do further cancellation. 18 factorial cancel with 20, what you left is 20 times 19, because all the previous numbers are canceled. And then you do cancel 10 factorial, cancel 8 factorial, so you get this 10 times 9 out, right? Because all the others from 8 to 1, that just canceled. Okay, so then what you left, then you do one more cancellation, right? So, okay, so maybe let me do it here. So it's 10 times 9, 20 times 19. So this is cancel 2, so eventually end up 9 over 38, right? 9 over 38. Okay, so for this approach, what we do is we just go with the standard approach, right? We just go with the standard approach. We find the total number of scenarios, and then we use that as the denominator. And then we find the number of valid cases, and then we just take the fraction. Okay? So that's the standard case. All right, now let's look at the second approach. So for the second method, what we can do is we can divide the problem into 2 steps. Step 1, we choose Mia to be in the morning. So Mia is in the morning, right? Okay, so obviously for that one, because she has equal chance to be selected for the morning session and also for the afternoon session. So for this one, the probability of course is 1/2, which this is obvious. Now step 2, okay, so given that Mia is already in the morning session, so Mia is already here, and what is the probability that her friend Joe will also be in the morning session? So this is, okay, so what is the probability that Joe is also in the morning, right? So this is the next step, like given Mia is already in the morning. All right, so then we see this is basically to say, okay, so I'm going to from 19 people, right? Because Mia is already in the morning. For 19 people, I'm going to choose 9 to be here, so which is 9, right, out of 19, and then we want Joe to be selected, right? So in this 9 people, then what is the probability? So this is reduced to the following question. Okay, so choose 9 out of 19. What is the probability? So what is the probability that Joe is selected? All right. Okay. So for this, well, which is basically irrelevant for the whole thing. So this could be independent question. So choose 9 from total 19, and I choose 9 out. What is the probability that one of them, so Joe, is selected? And the answer is 9/19. Well, intuitively, this is correct, right? It's kind of a portion, and there are different ways to see. One way you can see this is I can let's say we can have just 19 positions, right? Okay, so this is 19 positions. We can fix 9 of them, all right? Okay, in total 19 positions. All right, so the first 9 positions as fixed, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9. All right, now this is equivalent to say, okay, so now I have 19 people, so all the way 19 people. They randomly go to those 19 positions, right? So then what is the probability that Joe will go to one of those selected positions, right? 9 select positions. So here's 9 select positions, right? Okay, so which is equivalent statement. So that what I said is the statement, I have 19 people, I randomly choose 9. What is the probability that Joe is selected is essentially the same as I say I have 19 positions. I first specify 9 positions. Then I put 19 people randomly into those 19 positions. So what is the probability that Joe is in this 9 select amount picks one of those 9 select positions? So then from here, you say, oh, well, it's obvious. It's just 9 choose 19 because he has equal chance to pick any individual position. So it's 9/19. Well, of course, you can also go with combinatorial. So or if you say, okay, I am still not so convincing about this, then you can go with the combinatorial. So combinatorial means, well, you have 19. So or you can go with you have 19, you choose 9, right? So this is a total number of scenarios. And then you say, okay, well, the scenario that Joe is selected, that means from the 18, you choose the another 8, right? Because Joe is selected, and from the remaining 18, you choose 8. So that's the valid cases. Well, from this, you'll get the same thing, just 9/19. So this is, you can go with the standard approach again, or from here, you can just go with what I said. All right, so this is a general statement. So and anyway, so here, I hope you're convinced. For the second step is 9/19 after Mia is put in the morning. Then after that, Joe is also in the morning, is 9/19. All right, so then you just multiply them together. So final answer will be 1/2 plus 9/19. So this is like the basically like the multiplication principle. So it's 9/38. 9/38. Okay. All right. You can choose either way. So the first method, as I said, is we just go with right. So let's recall the first method 1 is we go with the standard, right? So we go with the standard. So that's the total number of ways you can divide people in 2 groups, and then the number of ways you choose 18, you choose 8, right? Because Mia and they already joined already in the morning, they choose 18 for 8. And then you do the calculation, right? So for this one, is the only thing is you need to be familiar with combinatorial, right? So use those, or you go with the second approach. For the second one, if you use sign intuition, you pick this 9/19. Okay, either way. Again, as I said, for those students who are not familiar with, well, let's say you're first learners, you're not very comfortable with probability, then I would suggest you go with the standard one. All right. Okay, so now let's look at problem 19. This again is a probability thing. Okay, so we have, so randomly choose 2 different numbers from 1, 2, 3, all the way to 12. So what is the probability that sum is divisible by 4? Now, obvious, okay, so let's say the probability we know is the number of valid pairs, right? Valid pairs means that sum is divisible by 4. And the number of total pairs. Now, total pairs is, it's clear, it's just 12 choose 2, right? So this one has no question. So this guy we know is, if you calculate this one out, so this one will just be 66, right? So this is 12 times 11 divided by 2 times 1. All right, so now you need to figure out the number of value cases. Okay, so what's the most efficient way to do is as it was put in the hint. Because here what you care about is divisible by 4, right? So which means that the thing that only matters is the remainder. So we divide 1/12 into 4 categories in terms of remainder. So in terms of remainder, when divided by 4, so we have 4 categories. So it's remainder 0, 1, 2, 3. All right. So for the 0, 1, of course we have. For the 0, 1, we have the first one 4, and then we have 8 and 12. So this is 1, 5, this 9. Then we have 2 and 6 and 10. So this is 3, 7 and 11, right? So each category has a 4. Okay. So in order, so I have 2 like x and y is divisible by 4. Then we have this 3 scenarios, right? 3 cases. Let's do case work. So case 1 is both of them have the remainder 0. So both of them are divided by, so let's say x, this is y, so 0 plus 0. And case 2, in terms of remainders, is both of them, when they are divided by 4, the remainder 2. So altogether is also divided by 4. Case 3, so it's 1 plus 3, right? So one is remainder is 1, the other one remainder 3, so altogether is remainder 4. All right, so how many cases right here, right? So let's say, okay, so this is just 3 choose 2, right? So from this 3, this is also 3 choose 2, because here you have 3. And this one is, okay, so you have 3 choice for this, you have 3 choice for this, because this is 3, this is 3. So this is 3 times 3 is 9. Again, here we use multiplication principle. Okay, so then here what we have, this is 3, and plus 9. So if you add together, you get 15. All right, so that means this guy, the numerator, so here is 15. So it's 15 over 66. We simplify this, so this is 5 over 22. So it's 5 over 22. All right, now let's look at the last one. So last one here we have 4 numbers A, B, C, D. Now they are okay. So pairwise products, right? So we have at the most we have 6 different products, right? Okay, because 4 choose 2, 6 different at the most 6 different products, and then we arrange them from least to greatest. Okay, so here this is least to the greatest. So it's 1, 2, 3, 4, 5, 6. It's going in this direction. All right. And we know the second one is 16. The third one is 28. And the fourth one is 36. And the question is, what is the fifth one? All right. Okay, so as it was put in the hint, because A, B, C, D is due to symmetry, we can just assume they are in this increasing order, right? So we just assume. Right? It doesn't hurt. Okay, so we can say it's A less than B, less than C, less than D. Then obviously, what is the largest one? It's okay, so the largest one, it has to be let me put this. All right. So the largest one has to be CD, right? So this one has to be CD, and the next one is BD. The smallest one has to be AB, and the second smallest is AC. Now, what is not sure is BC. So this one could be. So for the third one and the fourth one could be either AD or BC, either AD or BC. Okay. So, but in whatever case, you see what we have is, so this is AC, this is BD. So then what we have is 16 times the question mark. This one equals to AC times BD, which is the same as the product of two middles, regardless whether which one is AD or BC, but it's AD, BC, right? So it's AD times BC. So which is regardless which is which. So it's 28 times 36, right? Okay. So then what we have, we get this question mark. This one equals to 20 times 36 and divided by 16, right? So we can do this. Okay, so this is 4, this is 7, all right? So then you divide by 4. Okay, so this is 9, right? So then you get this 7 times 9, 71. So this is 63. All right, so here the main issue is the first step is you look at, you put the order of these four numbers, and you can easily decide which are the largest and second largest, and the second largest and smallest, second smallest. Now, the only thing which is to be determined, right, which is not completely clear, is the third and fourth one. But we have the this equality, right? So which means basically means the second one times the fifth one equals to the third one times the fourth one, and this will give us the fifth one, right? It gives us the fifth one. All right, and okay, so that's it. If you have any question, and we can discuss in the WeChat group. You can either send the question by yourself or through your parents' WeChat account. All right. I hope you enjoy working on those problems, and more importantly, I hope you can learn something from those exercises. All right. So these are all about the first quiz. Some of you might find that the problems are harder than what you thought, and probably had a hard time in solving some of them, which is completely normal. So please do not get discouraged and easily give up. Our team members will take turn to present solutions for AMC8+. If you stay on and follow the schedule, I believe your ability of solving problems will be improved definitely, probably a lot, after this sum practice program. Okay, that's it, and have a nice weekend.